Good morning, students. You have learnt about the definition of a complement of a set, and then the rule, the properties of the complementation of the set you have learnt. And we have worked out some problems also, where we have calculated A given A, U is given the universal set. When A is given, you can calculate A dash, like that we have done. Now, there is an important law which is called as a DEMORGAN'S law. I have given that under the properties of the complement of a set. Now, these problems, usually these problems are asked for a 3-mark question generally. Now, in today's session, I am going to work out problems in which I prove the DEMORGAN law. What are the two DEMORGAN'S law? One is A union B whole dash equal to A dash intersection B dash. That is, taking union then taking the complement is as good as taking the intersection of the respective complements. The other one is A intersection B whole dash. That means that taking the intersection of two sets and the complement of that one is as good as taking the union of the individual complements. Now, we are going to work out problems on that one. Now, first problem, let the universal set U be equal to 1, 2, 3, 4, 5, 6. Then the set A contains the elements 2 and 3. Now set B contains 3, 4, 5. So you have to prove that. First one, A union B whole dash, that's equal to A dash intersection B dash, and the second one, A intersection B whole dash is A dash union B dash. See, both of them will not be asked in the problem. Any one of them, either the first one or the second one, because each one is expected for a 3-mark question. Any one of them can be expected. Now, let me look at the universal set. It is containing 6 elements. A contains 2 elements. B contains 3 elements here. Now, let me take the first result is A union B. Let me consider A union B. What is the definition of A union B? That is, it is another set which contains the elements of both the sets. That is, A is having 2 and 3, B is having 3, 4, 5, 3 is repeated. Just write only once. So, A union B is a set having the 4 elements 2, 3, 4 and 5. Now, start with the left hand side. That is, A union B whole dash. That means, that is 2, 3, 4, 5 dash. Now look at the universal set. It is having 1, 2, 3, 4, 5, 6. Now 2, 3, 4, 5 are already there. So that complement of that means it becomes 1, 6. So this is the left hand side. Now let me come to the right hand side. What is on the right hand side? A dash intersection B dash. Here itself you can calculate A dash also. A union B have written. A dash means A contains 2 and 3, but for that the remaining elements, that is 1, 4, 5 and 6. And what is B dash? B dash would be 3, 4, 5 are there, 1, 2 and 6. Now A dash intersection B dash. A dash intersection B dash means 1, 4, 5, 6 intersection 1, 2, 6. So intersection means you have to take only the common elements. What are the common elements? 1 is present in both of them, 6 is present in both of them. So that would be equal to 1 and 6. You observe left hand side, A union B whole dash is having 1 and 6. A dash intersection B dash is also having the same elements 1 and 6. Therefore, we can say that the left hand side equal to right hand side. That is, taking the union then taking the complement is as good as taking the intersection of the individual complements. Now, this is the first part of the problem. Now, let us move on to the second part of the problem. Now, second part is here you have to take the intersection, then take the complement, and you have to take the complement, then you have to take the union. So again, let me write the union and that complement first. A dash means 2 and 3, omitting that one, 1, 4, 5 and 6. What is B dash? B dash is 3, 4, 5, omitting that one, 1, 2 and 6. The left hand side is A intersection B. Let me take that also. A intersection B. Now A is containing 2, 3, B is containing 3, 4, 5. What is the common element here? Common element is only one, that is a singleton. Now let me start with the left hand side. That is A intersection B the whole dash. A intersection B the whole dash. What is that one? 3 dash. Now 3 is the only element. So what is the complement here? If you take out the 1, 2, 4, 5, 6. So the left hand side is having the 5 elements 1, 2, 4, 5, 6. Now come to the right hand side. Right hand side is A dash union B dash. Already we have calculated A dash and B dash. So let me take the union 1, 4, 5, 6 and 1, 2, 6. So let me write it. 1 is common, then 4, 5, 6. I am writing all the elements here. Now and 1 is already there, 6. So take that 2 also. Need not write 2 times here. So it is 1, 2, 4, 5, 6. The order is different, but the same elements are present. So clearly we see that A intersection B the whole dash equal to A dash union B dash. So I told you both of them will not be asked. Any one of them will be asked. So you have to calculate the respective complements, either the union or intersection, depending upon what has been asked in the problem. Now let's move on to another problem where again we are going to prove the DEMORGAN'S law. We are going to verify. Sometimes they ask you prove that or verify. Now let me move on to the next problem. In this one I am having the universal set 1, 2, 3, 4, 5, 6, 7, 8, 9. So it is containing 9 elements and the set A contains 2, 4, 6 and 8. And the set B contains 2, 3, 5, 7. Now I am going to verify both the parts of the DEMORGAN'S law. That is, proving part is this only. A union B the whole dash, and then A that's equal to A dash intersection B dash. Next is A intersection B whole dash equal to A dash union B dash. The proof is same. The procedure is same, only the data is different. Now let me come to the first part here. First let me take the first part of the problem. For that now I have to calculate A is given, find A dash. B is given, find B dash. We need that on the right hand side. Then take the union and then we will take the whole complement of that one. So to take the first one, first let me write A dash. Look here, A is having 2, 4, 6, 8. 2, 4, 6, 8. Write the remaining elements 1, 3, 1, 3, 5, then 7 and then 9. Correct? 2, 4, 6, 8 are already there. Complement means omitting those elements. You have to write the remaining elements. Then find out B dash also. B dash 2, 3, 5, 7. So you can write 1. 2, 3, omit that one, then write 4, 5 is there, 6 and 7 is there, then 8 and 9. Observe, A dash is having 5 elements, B dash is also having 5 elements. We need A union B, that is combination of this one, we have to combine 2, 4, 6, 8, 2, 3, 5, 7. So let me write in an order 2, 3, 4, 5, 6, 7, 8. So here 4 elements, here 4 elements. Some which are the elements that have been repeated here. See, 2 is repeated, so there is no need to write 2 times here, you write only 1 time. Now these are the elements which are present in the union. Now let me start with the left hand side. What is on the left hand side? It has to be A union B, the whole dash. A union B whole dash means, see, go to the original set, the universal. 1, 2, 3, 4, 5, 6, 7, 8, 9. So here we are having 2, 3, 4, 5, 6, 7 and 8. So what are the remaining elements here? When you can write one more step here. 2, 3, 4, 5, 6, 7, 8 whole dash. Now see, 3 plus 4, 7 elements are there. What are the remaining elements? Only 1 and 9. So the left hand side we are having union of A and B, then taking the complement we get only 2 elements. Now come to the right hand side. What is on the right hand side? It is A dash intersection B dash. Already we have calculated A dash and B dash. Let me write the elements again. Intersection 1, 4, 6, 8, 9. What do you mean by intersection? We have to take those common elements which are present both in A and B, both in A dash and B dash. What are the elements? 1 is present, and then 3, 5, 7 they are not there, and another element is 9. So we observe that the left hand side, which is A union B the whole dash, contains 2 elements 1 and 9, and A dash intersection B dash also contains only 2 elements. That means the De Morgan law holds good. That's how we have to say. Now let me try to prove the second part of the problem, that are the De Morgan's, or the other De Morgan law. There also we need A dash and B dash, so we are already having the data. Now for the second part, A intersection B is needed. So let me consider A intersection B. What do you mean by intersection? We have to take only those elements which are common. 2 is there, 2 is there. So only one element is the common part. That means it is again a singleton. Now let me start with the left hand side. What is on the left hand side? A intersection B the whole dash. That means singleton dash. So omitting 2, you have to write all the numbers 1, 3, 4, 5, 6, 7, 8, 9. Because the universal set contains 9 elements, only 1 is there. So complement means we have to write all the remaining elements. Now come to the right hand side. That is A dash union B dash. What is A dash? We have already calculated. It contains 1, 3, 5, 7, 9. Union 1, 4, 6, 8, 9. Now repeatedly I am telling you, in the case of union, suppose the terms are repeated, no need to write 2 or 3 times, only 1 time it would be enough. 1 is present in both the sets, right? 3, then 4 is there, then 5 is here, then 6 is there, then 7, 8, 9. Only 1 is the number that is repeated. All the remaining numbers have appeared only once. So it is 1, 3, 4, 5, 6, 7, 8, 9. You observe that left hand side also had the same elements, right hand side also having the same elements. That means that the De Morgan's law, both the laws we have considered, both of them they hold good. Now to find the complement of a set when the universal set is given can be expected only for a 1 mark question. Whereas the De Morgan's law, they don't directly ask De Morgan's law because there are 2 parts here. So usually it is given for a 3 mark question, means they ask you any one of them, either A union B whole dash or A intersection B the whole dash. So such problems you can expect for a 3 mark question. Now I am going to work out some more problems which are called as practical problems. Practical problems means here the data would be given in the earlier problems that we worked out. A will be given, B will be given, universal set or whatever may be that one. Practical problem is most of them would be statement problem. You might have learnt about this in high school classes, statement problems. So you using the statement that has been given, you may have to denote something. Suppose some particular word is given, you can take an alphabet to denote the particular set and all. Now, to work out the problems, the practical problems on union and intersection, we should have some knowledge, that is some new formulae I am going to give you. Now, this proof of this will not be asked. You have to know only the rules here or the formulae. Using them only, you can work out the problem. Now, we consider two sets, A and B. Here, I am discussing only about the finite sets. Finite set, what do you mean by finite set? It contains only number which can be easily told, that is, we know the exact number of the element. That is the meaning of finite. Infinite set means we do not know the exact number of elements. In the finite set means it may be a huge number also. Still, we will be knowing how many elements would be present in that one. Now, let me these are called as the practical problems on union and intersection. Now, for that, let me take two finite sets A and B. That means I know how many elements will be present in both the sets. Now, here two possibilities are there. And when I started this particular chapter set, I had mentioned one word, cardinal number. Cardinal number, we use that word only for a finite set. The number of elements in a finite set is called as the cardinal number. Suppose it is suppose A is having 10 elements, then we write NA is equal to 10. Suppose B is having 25 elements, I write it as N of B is equal to 25. So when you use N here, small letter n, inside the bracket you write the set here, then the number on the right hand side gives how many elements are present in that one. So this is known as the cardinal number. Now A and B are finite sets. I am considering these are finite sets. These are finite sets. Now, first possibility is here A and B, they may have a common element, may not have a common element. A intersection B, suppose it is a null set. Suppose it is a null set. That means that there is no common element at all. In that case, we use it N of A union B is equal to N of A plus N of B. If I simply write this, you may find difficult to understand this one. I will give an example. Now, first let me know the meaning of this one. If A intersection B is a null set, what do you mean by null set? Doesn't contain any element. In that case, the elements in the union of A and B is actually the sum of the elements of the individual sets. That is the meaning of that one. You take the total elements of A union B, that would be equal to sum of the elements of the individual sets here. Now, I will give an example. Suppose A is having 1, 2, 3. B is having say 4, 5. Clearly you see that there is no common factor at all, isn't it? That is, there is no common element, I mean. How many elements are here? 3 elements. How many elements are there? 2 elements. So totally how many? N of A plus N of B would be equal to 5. 3 plus 2, that is 5. Now take the union here. A union B is a set having 5 elements, correct? Now when you take the union A union B, N of A union B, that would be equal to 5. This is the meaning of that one. If they do not have any common element, in other words, if the intersection is a null set, then the sum of the elements of the two sets is equal to the elements of the union of the two sets. That is the meaning of that one here. Now, let me move on to the next part. Here, in the same thing, suppose A intersection B is not a null set. What do I mean by that one? There may be, at least there is one common element. In that case, the result is little bit different. That is, N of A union B equal to N of A plus N of B minus N of A intersection B. N of A intersection B. That means that when you A union B, when A intersection B is not a null set, but it means it may be containing some, it will be containing some elements. In that case now, n of A union B would be sum of the elements of the sets A and B minus the number of the common elements. I will take the same example by making slight change in this one. See, let A contain 1, 2, 3. Let B contain 3, 4, 5. Now you observe that 3 is a common element. Therefore, A intersection B is containing 3. Therefore, it is not a null set. Now, let me take the A union B here. What is A union B? 1, 2, 3, 4, 5. Just like the previous problem only, previous example, 1, 2, 3, 4, 5. How many elements it is having? 5 elements. N of A union B is equal to 5. Now, come to the individual thing. N of A plus N of B. See, N of A means it is 3. N of B, that is 3, it would be equal to 6. But what is N of A union B? It is only 5. So, that is what we are doing here. We are adding the number of elements in the sets A and B and we are taking out the sign. And what is A intersection B here? A intersection B is a singleton. Therefore, what is N of A intersection B? It is 1. So, from that one I am subtracting, that is N of A plus N of B minus N of A intersection B. That is 6 minus 1, that would be equal to 5. So, this is also 5, this is also 5. So, when there is a, then it is a null set. When the sets A and B are disjoint or they do not have a common element, then the formula reduces to only this much. N of A union B plus N equal to NA plus NB, N of B. Suppose there is a common element, it is 1, then N of A union B, NA plus NB minus N of A intersection B. That means we take out the number of the common elements from the total of them, that gives us the actual value. Now, these two you have to remember. Of course, the first formula comes as a particular case of the second formula. If there is no common element means N of A intersection B becomes nothing, 0. No element would be there. So, it is as good as writing, but we write them separately. Now, let me move on to the third one, third formula. Suppose you are finding the elements of the difference of A and B, N of A minus B. Of course, A and B are finite sets only. Whenever I use this cardinal number, they have to be finite sets. N of A minus B is obtained by the formula N of A minus N of A intersection B. N of A minus N of A intersection B. That means that, see, but the order is important because we have learnt about in discussing about the operation difference. Say A minus B is not equal to B minus A. That is, the difference is not commutative. Therefore, first we take the elements of the set, first set A. From that one, we take out the number of common elements of A and B. That gives you the N of A minus B. I will take an example here. Say A is having, let me take the same example. A contains 1, 2, 3. Let B contain the elements 3, 4 and 5. Now, what is A minus B? How do you define A minus B? It is a set containing the elements which are present only in A but not in B. What is that one? It is only 1 and 2. So, these elements are present only in A but not in B. 3 is present here also, so that cannot be taken into consideration. So, how many elements did I get here? Only 2 elements here. That is the meaning. And what is A intersection B? A intersection B is a singleton, that is 3. Therefore, when you take the cardinal number N of A minus B, N of A minus B is 2. Okay, N of A minus B, that is the left hand side, the number is 2. Now, take the right hand side, N of A, how many elements are there? N of A means it is 3. and n of A intersection B. See, A intersection B is 3, that means that implies that n of A intersection B is equal to 1. Don't get confused here. A intersection B means it is a set, gives the exact elements here. N of A intersection B means it gives the number of elements in that one. Don't get confused here, because these are two different, this gives the elements directly, that gives the number of elements here. So A intersection B has got only one element, so I can write it as 1, 3 minus 1, 2. That means the left hand side equal to right hand side. This is how we have to calculate. That means that the order is important here. N of A minus B is n of A minus n of A intersection B. Another part of the same thing. Suppose I take in the reverse order, n of B minus A. How do you write this one? It is n of B. Here A was the first set, first I have written. B is the first set I am writing. But this part is common. It is A intersection B. Now take the same example here. Now A is 1, 2, 3. B is containing 3, 4, 5. Let me write B minus A. B minus A means those elements which are present only in B, not in A. That means 4, 5. Now take the number of elements. This is giving the set in the roster form. I am finding the elements. How many are there? B minus A also has 2 elements. Now here n of B, you know, it is n of B is having 3 elements, and then what is A intersection B? A intersection B is again a singleton, and what is n of A intersection B? That is 1. So n means gives the number, and A intersection B gives the elements here. Now come to this part. N of B minus A, that is equal to 3. N of B, what is n of B? How many elements are there? 3 are there. So n of B minus A, n of B minus A we have calculated here. B minus A is 4, 5. N of B minus A is 2 here. N of B minus A is 2, and n of B is 3 minus n of A intersection B is 1. Again we got it to be 2. Of course, if I had omitted one term here, it would be different here. Therefore, n of A minus B is first write the first set minus the intersection elements. B write first and write the intersection elements here. So these two would be same, but the order is important. A minus B is different from B minus A. So if A minus B is there, you take A. If B minus A is there, you take B. That is the rule here. Now, suppose I consider one more set here. That is A, B, apart from A and B, let me consider one more set C. Of course, C is also a finite set. So taking 3 finite sets, that is A, B and C here. This statement you have to remember, it's a lengthy one. We will be using them in certain problems, because when 3 sets are there, how to find the union of them? A union B union C. Of course, you have learnt in the associative property, in whatever order you combine, you will be getting the same number of elements. Now the formula is quite a lengthy formula. Remember it properly. N of A plus N of B plus N of C. First we add the elements of the each set individually. From that we take out, that is we subtract A intersection B minus N of B intersection C minus N of A intersection C. I am taking 2 at a time. Then add the common element, that is A intersection B intersection C. So this is the formula. Quite a lengthy formula. This will be using only in certain problems where 3 sets are involved. But how do you remember here? A, it is an extension of 2 sets here. What we learnt in the first part. A union B union C equal to N of A plus N of B plus N of C. We add the number of elements of the 3 sets. Minus, we take out the common elements of taking 2 at a time. All the 3 we cannot take. So A intersection B minus B intersection C minus A intersection C. Again, there will be some elements common for both, all the 3 of them. Therefore, we add that common elements here, n of A intersection B intersection C. The derivation will not be asked. So, this is quite a lengthy formula you have to remember. So, to work out the remaining practical problems which you will be learning in the coming sessions, we have to remember all these one. That is, when there are two sets A and B, if they are disjoint, then n of A union B is NA plus NB. If they are not disjoint, there is a common, at least common element, NA plus NB minus N of A intersection B. Then the difference, N of A minus B is N of A minus N of A intersection B, similarly for that one. And the fourth one, this is the one where we will be having three different sets, all of them of course finite sets only. Then we can use this formula. So, by heart all these formula, the derivation will not be asked for you. So, by heart these formula properly, then we can work out the problem. So, in the coming sessions, I am going to work out what we call as the practical problems. Practical problems means sometimes it would be given in the data would be given to you directly. Sometimes we have to make some notations and then you have to get the result here. Thank you.